Okay, our next presentation is going to be from James Lee and Seamus Cunningham. James Lee is from Abbott Nutritional. James comes to us from he's the University of Cincinnati. He's a Bearcat there, Sam. There you go. And so James comes to us, and he's worked at, well, you were at Nestle's as well, right? General Mills and Nestle's, yeah. So he's he's the engineering manager over there at Abbott Nutritional. And we have Seamus Cunningham. Seamus comes to us from Seeq. What's your exact title? Analytics engineer. He's got a degree from mechanical engineering. I believe Sheldon Cooper calls it that trade college, MIT. Yeah, that trade school. So anyway, they're going to do a presentation talking about how they're using the data and tools around sustainability and trying to minimize the consumption of raw materials in the production of the products. Okay, thanks. Clicker right here. You're wired up.
Well, good morning, everybody. So I'm obligated to go through some slides about Abbott Abbott overall. So bear with me a little bit. So Abbott has been around for about 125 years and more. So I think many of you guys heard of Abbott across different divisions. So we have a nutrition, diagnostic, medical device, and generic pharmaceutical. So I'm representing the nutrition division. So nutrition is pretty much a consumer front-end basis. We break it down into pediatric, adult nutrition, and performance. So this is the brand. So typically you see the big old Abbott sign. You don't mean anything because it's hiding behind the hospital for blood work analysis and things like that. So nutrition is the brand focus of Abbott. So you have Similac, Ensure, Pediasure, things like that. So if you have kids, you know what I'm talking about. So that's where we're going to focus our presentation based on nutrition manufacturing side. So, Seamus?
Yeah, great. So I'm Seamus with Seeq here. So Seeq is a time series data analytics application. So we plug into and support all of the entire PI system. So from kind of on the simple side all the way from straight PI tags all the way through AF servers and event frames and publishing notifications between the two systems and actually publishing displays to integrating with PI Vision. So in addition to, we're going to be focusing a lot on the contextualization capabilities of the product, but other things that we're working on with Abbott and with other customers include things around machine learning and modeling and boundary management, regression analysis, a lot of integrating data sources across different sites. And the goal of the application is to really give end users, maybe click one more. If you give end users an ad hoc application, so to really try to get people out of Excel as much as they can for those one-off and two-off different analyses people are doing, and to bring those offline Excel analyses online so they can run in real time and be shared across a group.
Okay. So put that frame in mind. I know yesterday afternoon we spent a lot of time event frame. So put that in the back of your mind as well, because eventually this will tie into event frame use case.
Oh, there we go. All right, the final animation. Anyways,
yeah.
That's basically everything I just said.
All right, a little bit of history. So Abbott Nutrition, or Abbott overall, has a long journey or long history with the OSI Pi, and now established with Seeq. So this year we actually start the enterprise agreement with Seeq for this year. So, but over decades, we have a year agreement with OSI Pi as well. So, couple of we're going to go through this fairly quick, and then we're going to save some time for question answer, and also in this afternoon we'll have panel sessions. So feel free to ask any question. So we'll have two use cases to show you. One thing is very similar to yesterday's conversation about CIP. So we're going to use our nutrition side CIP, for example, technical challenge is basically we have a whole bunch of data through all the decades collecting data in OSI Pi, all time series. How do we break it into event basis? And also, how do we extract the massive data into what's critical data? So that's the technical challenge that we have right now. And currently, we have knowledge. Basically, we use the Pi a lot using for event troubleshootings. So engineers love it. But operation and also business executive leadership, they don't really familiar with the Pi because how do we extract the time series information into some type of tangible business use case? That's the challenge right now. So we won't go through that in detail. And just clicker. Second use case is batch monitoring. Again, is more based on event frame. We basically how to put context information and draw out from time series data into each individual process on different batches. So we have identified 3 things that we try to do for sustainability reasons. One thing is the batch durations. So how consistently we can run the same batches, the same batch size on a consistent basis. Second thing is mass balance of production, throughputs. From each batch process, how do we measure the throughput? And third thing is in the future, we're going to tighten utility consumption as well. So today's use case, we're going to focus on the mass balance. The second, the production throughput. Okay?
All right, great. So this is a little bit of what the application looks like and what kind of the engineers are viewing when they're actually running the analysis. So this is what we call a workbench analysis. So inside of here, kind of on the upper left, you see we have in this analysis there's a bunch of different views or different intermediate type of products where people are developing calculations and they're trying to tell the story. So how do you take all these disparate data sources and time periods of interest and really assemble it together into a continuous story? So you can kind of think of these as like tabs in a spreadsheet or like slides in a PowerPoint deck. In the tool panel is where you can take all the different add context around all those continuous data streams that are coming in from Pi. So from the very simple, as you mentioned, kind of like threshold calculations all the way through to very complex combinations, and we'll show a little bit more about that. That context actually showed as what we call capsules across the top of the screen. You kind of see all those little dots and bars. They're just marking little time periods of interest, and so you can use them very flexibly to combine together to say, hey, I want this and this, but not when this is running. And it's a nice way to take continuous data and make it look a lot more transactional. And again, all that context is being built off of the high-speed data that's inside of the Pi system. And when you kind of overlay the context on top of the process data, you get at the bottom stuff that looks a lot more like a table. So you have actual start and end times where you can actually run aggregations, do statistics, and that kind of stuff. So this is what kind of like when you're working in it, what kind of like the work process looks like a little bit.
Can I add something?
Yep.
So right now, earlier we mentioned this is what engineering troubleshooting for. It's continuous data. But what you're going to display is visually on top, basically kind of event frame capsules on top, and also summary piece for the other audience as well.
Yep.
Next.
Yep. Great. So again, we kind of talked a little bit about this yesterday, especially contextualization and why it's important. So again, we got Abbott's had a Pi system in some of these sites for over a decade, and so there's lots and lots and lots of data in there. And so trying to pick out the individual time periods that we really care about helps take massive problems and make them a lot more manageable. So marking those time periods can come in a number of different forms. So they can come from calendar events, so just like, hey, every Monday or every first shift. They can come from searches, so those threshold type searches of like when we're above a flow rate for a given amount of time. And they can also come from external systems. So they could be from SQL tables, like maintenance data, as well as actually coming in from Pi event frames. So if you have existing event frames that you want to bring in and use in your analysis, you can integrate with those as well. And all it is basically, again, kind of slicing the continuous data into something a little more manageable. Like everything like batches or all kinds of different stuff. And the real magic is being able to kind of combine these things together. So giving engineers a real visual way that they can ad hoc come in and start taking, all right, I want to know when we're in this CIP flow system and we're running this shift and we're in the right step number, or this and this are occurring, but this isn't occurring. All those kind of logical operations that almost look a little bit like SQL type joins, where you're kind of doing inner and outer joins. We want to make that really nice and easy and visual so that people can follow their steps through the process. And once you have those important time periods of interest, you can start doing statistics and aggregations. So this is really where that business value piece comes in. So how do we take the squiggly lines and turn them into numbers that people care about? And so that's where the actual context has statistics in it. So like, how long is it? How long did the CIP event take? But you can also use the start and end time to aggregate your continuous data. So those would be things like, what's the totalized flow rates, and what's the max conductivity? Are we reaching our set points where we should be?
Good.
Yep.
So that's some technical background, the methodology we're going to use for those two use cases. So first thing is kind of brief background on CIP. I know we probably went through that yesterday afternoon, but pretty much a CIP breaking down into circuits. So you have a one centralized CIP system that goes into each process, cleaning place, and then throughout the circuits we have different phases, like caustic phase, rinse phase, and things like that, so on and so forth. So we basically, those are the process background that we're going to use using to build a capsule. So next step is characterizing the CIP process. So again, we use the continuous data set right here, and we'll start building our capsules. So we will tell you basically when is the continuous time, is when you run in production, when you run CIP, when you idle, because we're going to try to build capsules capture 24/7 clock. From that, we can break it down into kind of parent-child relationship of the capsules. So within the CIP, when do you use the acid clean, caustic clean, and final rinse? So just kind of summarize that based on the capsule, we build a circuit capsule and phase capsules. We basically try to identify, overlay. You can see duration of that, and then you can summarize based on the previous screen. This is a little bit more zoomed in, basically on the duration time. So right off the bat, an engineer to do initial ad hoc analysis, you will know how long duration-wise for each CIP cycle. And you can go back history in time. I actually went back for past 3 years of the Pi data to find out certain times of why we spend so much time on CIP, or we double CIP sometime. Okay. And one more thing is water rinse savings is a big focus, because sometimes we are kind of follow out the old-fashioned way to rinse. We rinse by time, right? So right now we try to evaluate the duration of the CIP rinse versus conductivity. So when you reach a certain conductivity, maybe we need to stop rinsing it. So right now we spend twice the amount of time rinsing it, instead monitor some kind of analytical sensors online. So those are the things that kind of draw out based on the capsule analysis.
Yeah, I would say that this is kind of the piece where you're taking kind of an ad hoc hunch of, hey, we might be over cleaning, and being able to quickly kind of put the numbers to it, say, okay, this is what the size of this opportunity looks like, so that you can share it and get funding and make capital requirement arguments.
So in capsule building is very similar to event frame generator on Pi Analytics. Is basically you have two data. So out of the massive data we're collecting over 25 Pi servers, and each server has more than 10,000 tags. But we only need two. Basically, you have your flow rate and the phase step number. We can generate all this. So again, that's basically, you can see this massive capsule, parent-child capsules is basically what I'm talking about, covered 24/7. From this, you can pretty much break it down in production and CIP. And under production time, you say when is running, when is waiting for product. So what's that tell you? Direct OEE, right? So if you running more than waiting for product, you get more out of your asset. And CIP, same thing. When you're running, when you're on hold, but you can dive into more detail each individual phases. You can use the same methodology for any type of process if you wanted to, but it's just using the same technical background. So key metrics is total versus time per mole, total water usage, and also what I mentioned about P conductivities, and also low conductivity too.
Great, and so that prior view, again, that's kind of that engineering view. So people who are actually running the analysis and kind of experts on those systems, they're looking at the squiggly lines, but it's not as useful for everyone in the organization. So you got to summarize some of that stuff up. So you can also take those views that we were looking at and start aggregating them and say, okay, what % time over the last week are we in these different modes of operation, and really start building out your red, yellow, green type scorecards. And so those scorecard metrics in there are doing things like, again, how long are we waiting relative to targets, or what's the total CIP flow rate for this particular asset versus other assets, as well as creating filtered views. So those ones on the far right over there. At the top, just kind of showing those durations of each of those modes of operation as a bar chart. So you got kind of those top green bars are just kind of showing you, all right, for each individual shift, how long are we spending in these different modes of operation. And then also filtered views. So, CIP doesn't occur all the time. And so you might want to just have views that filter it down so that you can evaluate, hey, these are the last 10 CIPs we've run, and filter out, the days and days worth of, normal production in between.
So just by looking at this is what I need to do some root cause analysis on this, because the higher duration CIP runs. So why cause that? So you can investigate, do more investigation, maybe a greenbelt project or something like that to dive into it.
So all those different individual views, you can start assembling together into kind of unified dashboards and working reports. And so this is in the kind of companion product to the analysis is our topics, and they feel a little bit more like a Word doc. So in here you can have live updating graphics from all those different analyses you're doing, and turn it into something that looks a little bit more like a daily stand-up report or something people are checking in with every morning. So all those metrics that we built, those % times in different modes of operation and filtered views, they're all live updating on a schedule. So as soon as data comes into Pi, these graphics are going to be live updating. But it's a nice way that groups can collaborate and write their work and task orders right alongside the data. So it feels a little bit more like a Google Docs type experience rather than having emails sending around all the time and everyone editing and changing things on different scales.
Yeah, for operation purposes, since this is a weekly report, instead of diving into each individual, in this case, fillers, we obviously need to focus on filler B and filler C, because based on the percentage, the duration, and the way we leverage the production assets, we can do a deep dive right off the bat based on the scorecard indication. Okay, so result and benefit for that use case, I know it's very high level summary. So clear visualization of CIP duration, that's definitely the win. Reduction of overall CIP duration. For the dryer portion, we reduced by an hour. Obviously, we set a glide path, the baseline, from all supply chains. So all dryer had to meet a certain CIP duration time. So we were able to use visualization to drive down by an hour. But again, this is more administrative control, standard works type of effort. It's not closed loop control. Don't think it's kind of APC type of effort. This is basically culture using the data. Consistent CIP operation phases create baseline glide path. So right now, instead of looking at each individual CIP cycles, we kind of take a look at back and how we perform quarterly, monthly, and things like that. How well we control a certain phase of the CIP phases. And next turn opportunity, like I said, water consumption, we can build into that, and also using conductivity to basically further reduce the duration of the rinse time. Okay? So next one, batch. This is basically very high level. I think everybody in this room knows the batch operation. The challenge is compared with the continuous process, batch process, is because we need to puzzle all the different event frames all together. So instead of showing everything by time, we got showing everything by batch. So that is the business operation challenge. So what we try to do is contextualize the summary status. Very similar thing, same concept. So we have continuous data. So in this case, this is the low cell weight. So again, main focus is the overall throughput. So you have a low cell and do each individual dump. But for our control system, our instrumentation, we don't have a loss in weight type of capability. So we got to look into how much actually dump throughout that cycle. But we cannot take the assumption that maximum of a low cell is accurate enough because we're talking about huge bulk silos. So we got to take a look at the range every single dump. So we're using capsule capture this tiny little pieces right here. Every tiny dump, you capture the difference, the range between the maximum and minimum. So if there's any kind of build up in the silos, that we will take into account for. So within this capsule, we can calculate the range of each dump consumptions of that blend. And then we aggregate those within the batch into a total weight. So those are the mass balance that we're doing for one of the area, but we're doing entire manufacturing process that way.
And I'd say this is pretty common, where like systems are undersensed, or you wish there were virtual sensors. So a lot of things of intermediate steps of how do you take what you have right now and get to those end goal numbers. So like I think with this one we had to do like a derivative calculation to find out when that was actually dumping, and then all those kind of intermediate steps are sitting in between the raw data and that value at the end.
So if you look at this, we're taking one single pi tag and do the aggregation derivative to figure out what the process is doing, and then articulate it and translate into some kind of common language by batch. So tracking batches to do the process. So this is your slide, I think.
Yep. Yeah. So we can actually take all of those different analyses that we just did and export them into an external tool like Power BI and start to make those connections between batches. So each of those kind of ad hoc investigations, so as you're kind of tracking the product as it goes through different assets, we can create a table kind of marking those, how much was going into the product in each of these different steps, and then export the tabular data into Power BI. And so in Power BI, it's really easy to make the connection. Just say, oh, this batch ID is the same across all these different tables, and then that's where we can kind of do the assembly of other views, which I think you're going to see in a bit. But the real kind of trick of this is that Power BI doesn't do as well with a lot of those intermediate calculations, so those things like derivatives and trying to do integrals under curves and stuff like that. But if you can get the analysis complete first and export the finished tables, we have a lot more success.
So take a look at the each individual export to a Power BI. We break it down our manufacturing process by 6 different areas. Each area have a different assets running the same thing. So average about 3 or 5 assets per area. So if you aggregate all together, you got a combination of 15 to 20. Those flat files basically generate from the Seeq using Pi data. And now we're going to do the final reporting in Power BI. I can point in certain directions. Can I talk about this?
Yeah.
Okay, so at the end, this is the final report that we're looking at. So basically, earlier we were talking about capsule building to do the initial cleansing analysis, and then we do the export into Power BI, and Power BI do final visualization. In this visualization, what you see is everything lists by time. So you can see zooming on every single time period. So this is the entire about 1.5 years, 18 months. So once we build a capsule, and list by the batch number. So we can do a search by batch number. You can basically have a chart to tell you based on the aggregation that we've done so far. So all this is basically intermediate storage. So I'm very interested in the OCS. Me and Todd kind of talk in the break section. How do you convert this into OCS, into some type of business analytics we're doing AWS and Hadoop. going forward.
Yep.
Okay. So result and benefit for a second use case of batch is basically mass balance of the calculation. Right now, we basically didn't do anything. If we do anything, it's very ad hoc at each individual engineer's spreadsheet file. And those are very hard to consolidate, and we actually compare apple to oranges sometimes. So we consistently basically standardize that point going forward. Visualization, production losses. So right now we kind of show you a first view of the Power BI. Right now we're in process of building the waterfall analysis across 6 different areas. So we know from beginning how we're going to make a batch from ingredient side or with the finished good, where the power loss and do the waterfall. And future opportunity, duration tracking by SKUs. We got different product family like Ensure and Pediasures and things like that. So we want to track batch durations so we have consistency going forward. And then utility consumption. Again, bring the utility cost into it, into pieces. So everything is basically, we set the foundation of it. And later on, we can add different analysis on top of it with different business use case. So that's kind of wrap it up in the half-hour presentation. I kind of leave time for a question and answer session. So based on use case, any question at all. I think it's very straightforward, I guess.
So you'd said, are you guys basically running like Seeq constantly all the time through some kind of scheduled process, or how are you doing that integration to make it to where Seeq's always creating these capsules for you and then getting it to where Power BI can have it?
Well, Seeq is kind of used on demand basis. So when we want to do a capsule, it's basically sitting there. So when we want to go back in time, when we want to do query, we basically do the query on demand. So it's not running constant all the time.
Okay.
Yeah, so that's in development right now. So yeah, so it'll be in one of the later releases this year.
Thanks.
Kind of a continuous data.
Hi there. Does the Seeq application do any backfilling of capsules?
Yeah, so it runs it live on whatever time range you're looking at. So you kind of zoom back to whatever time, and it runs the calculation on that. And it's kind of on an on-demand basis. So the only thing we're storing is the definitions on how those queries are built. And then when a user requests it over a time range, we go and grab the PI data and then run the analysis and display the results.
So all the heavy lifting is actually in the Pi. We have a large Pi archive across all the sites. We actually have one very lean Seeq servers to do the query.
Any questions? Okay, well, we're a little ahead of schedule, but we're going to start lunch at about 11:45. But I'll tell you what we can do is we still have those the demo pods back here, and Seamus and John and Teresa from Seeq and James will be there as well, and you could talk with them, and we can also talk to about Pi Vision. So, all right, thank you very much.
Thank you.